if you're not able to see what's going on or whatever. Yeah, so today I'm going to talk about Kotlin. So for those of y'all who aren't familiar with the brown bags that I tend to do brown bags on crazy languages that no one's going to use. So hopefully this one will be a little bit different in that sense. There's a theme throughout most of the talks that I do around, just please God, no more Java, please no. And so this is kind of in that same vein. Trying to talk about some different things that we can use to write software, and this one might actually be one that people might use while it's falling, which is cool. Yeah, so today the kind of high level what I want to do is talk about Kotlin, what it is, why you might use it. I'm going to be doing that through a live demo of taking a very simple Spring Boot Java app and converting it to Kotlin. And then also the main attraction, I think, is going to be watching me fail to do this all live and maybe save it with Git. Yeah, so Kotlin's a programming language. Specifically, the kotlinlang.org says it's a modern programming language that makes developers happier. It is not very opinionated. It's not, you must do things in this particular way. It tries to be a very pragmatic language that allows you to solve problems in a bunch of different ways. And so that's what's kind of appealing about it. Is it allows you to, do a lot of the same things you're doing today, but just a little bit nicer and with some, polish on top that you may have not had before. Compared to some of the other stuff I've talked about in the past, it's not transformative. It's not asking you to solve problems in super different ways, but it is giving you a tool set to do things in a little bit easier way for sure. So Kotlin was announced in 2011. By JetBrains. If you're not familiar with JetBrains, JetBrains is a company that makes IntelliJ, ReSharper, Android Studio. Basically, like the best IDEs on the market, in my opinion, are made by JetBrains. And JetBrains basically wanted a language that they could use to build their IDEs going forward. And there was no language that had all the features they wanted. They said Scala was pretty close, but Scala takes forever to compile, and that was the deal breaker. And so they decided to do this project Kotlin. The name Kotlin actually comes from a language outside of St. Petersburg in Russia, kind of alluding back to the fact that Java is also an island, that kind of stuff. You can think of Kotlin as like a spiritual successor to to Java. You'll see a lot of Kotlin libraries use a K, where like a lot of Java libraries use a J, that kind of stuff. In 2015, Kotlin hit 1.0. And so all that means is it's been stable for quite a while now. I think we're about to be at 1.4. Not too many huge changes since then. The biggest is maybe like an increased focus on coroutines that came with like 1.3, I believe. The big thing for Kotlin, and the thing that I think that makes it most compelling, is that in 2017 it got first-class support for Android and for Spring. And so all that means is that right now for Android, if you want to write an Android app, it's going to be written in Kotlin if you have any sense. That's kind of the where the platform is going. Kotlin was kind of Android's answer to the Swift transition that iOS had. And also Spring is coming along with Kotlin as well. You can do everything in Spring that you could in Java in Kotlin, and part of that's due to the way Kotlin has been built, but there's also some increased functionality added on to Spring by Kotlin due to the fact that there's interesting things around DSLs and that kind of stuff. That we probably won't get into today. And then 2021, maybe in the future, world domination, Java burns, and the Kotlin looks over the ashes or something like that. I don't really know. Cool. So one thing I think that it's important to kind of preface this talk by saying is that pretty much if y'all have been here for long enough, you've probably heard me get up in front of y'all and talk about a dumb programming language that you'll literally never hear about ever again. And I just want to kind of contrast those talks to this one by trying to outline kind of where on this grid of like pragmatic languages to more pragmatic languages and more opinion languages to less opinionated languages. I think if you look towards that top right quadrant, that's kind of where you want to be for a language that actually is going to be productive for consultants, because we can't usually afford to come into a client and say, y'all should all use Haskell because it is, it's strict functional typing makes it impossible to create errors or whatever, because it's just not productive conversation to have with a giant company. So Clojure over here, not very pragmatic, not very pretty opinionated. Same with Elixir. Elm is another one, but Kotlin tries to be over here on the right, which is kind of what we're going for. Yeah, so now I'm going to jump into a live demo. I had a bunch of slides and I kind of threw them all away because doing slides and just talking over them was just not very productive for me doing this virtual thing. So have patience with me as I kind of work through the best way to accomplish all this. All right, so one thing I want to say for this talk is, first off, I want to make sure y'all can read the code on the screen. And second off, this talk is not meant to be an expansive exploration of the Kotlin programming language. What it's really supposed to do is for you to come away with, as a Java developer, saying, it would be really simple for me to play with Kotlin and learn more. That's really all I'm going for, is just to say, hey, Kotlin's an option. Kotlin has some cool things that I want to try, and the cost to do Kotlin is so low that it's worth giving it a shot. All right, so I have this really simple Spring Boot application here. It's a very simple microservice that returns some recipes. Those recipes don't exist right now, but we don't really care about that. So over here, we have our Spring Boot application file here. We have a controller. We have a repository service with some logic in it. We have some enums and some data classes, some pojos, and then we have a couple utils and that kind of stuff in it. So the first thing we're going to do to add Kotlin to an application is in IntelliJ, if you just go to Tools and Kotlin, configure Kotlin in project, you're going to select all modules, hit OK, and you're ready to rock and roll, right? IntelliJ is going to add Kotlin to your Gradle, build.gradle file for you, configure the Kotlin compilation targets, and all that kind of fun stuff, all right? So at this point, now you're ready to start writing Kotlin. So if you want to add a Kotlin file to your application, you can do that. I'll create one called foo.kt. We're not going to add it to Git. Kotlin is kind of neat because it allows you to do a bunch of things that you can't do in Java, one of which is package level functions. So functions don't necessarily have to be in a class. So this is just a test function, and it's going to return a string. And this is how we declare functions in Kotlin. We use this fun keyword, and then we give the name of the function, and this is where the parameters would go, and this is the return type. In that, it works pretty similar to Java. If you have a string, you can return it. And yeah, that's pretty simple. Hopefully, a lot of this looks pretty unremarkable. It's not, its familiarity is a feature, not a bug. And the ways it deviates from Java are meant to be for productive reasons, not just because it wants to do stuff differently. Also, you don't need semicolons in Kotlin, which is kind of nice. I'm probably going to get rid of my face as well. Can y'all see the code on the screen well enough? Somebody else want to pipe in and see, do I need to up this font size? I'm going to do it anyway.
Looks good to me, Donnie. I'm watching the stream on another machine, and you can actually see it a lot better than you can most of our live coding presentations, I'd say.
Oh, yeah, cool.
I think if you can make it just a hair bigger, for anybody that's looking at it on their laptop, it might be a touch small.
Sweet, I can do that. Thanks for the feedback. All right. Oh, and this is going to go to Monaco because that's by far the best code font. All right, sweet. Is that a little bit better? Cool, I'm going to assume so.
That's
all right, awesome. So one of the cool things about this presentation, the idea is we're going to convert this app from Java to Kotlin. And the cool thing is there's a shortcut to do it. So it's just Command, Option, Shift, K, and that'll convert to Kotlin. And all right, there we go. So that's my presentation. Y'all have a nice day, right? No, obviously that's not true, but it is really simple to convert stuff to Kotlin in IntelliJ. It does do that for you. Actually, if you have code on your clipboard that is Java and you paste it into a Kotlin file, so if you're like on Stack Overflow or whatever, IntelliJ will literally convert it from Java to Kotlin for you, which is really nice. So converting our Spring application, one thing we need to do is move this main method out into a package function, which we can do here. And then instead of this being an object, which I'll talk about later, we're just going to make this a class. And because of the way Spring works, in Kotlin, classes are final by default. So we need to make sure it's open so that Spring has the ability to do some of the configuration things it needs to do. All right, so that's our file converted to Kotlin. Pretty simple here. Looks really similar. Once again, you just have the your parameters here, the types of those parameters there, and then your function body, right? Not too crazy. Cool, so now we're going to go to what is probably like the simplest thing you can think of in Java, which is just a pojo. So I have this recipe class here. This is just meant to be like a container for some data. So it has getters and setters with some private instance variables, all that kind of fun stuff. It has its two string methods, its equals, and its hash code. So the first thing I'm going to do is you can also right-click and convert Java file to Kotlin. So I'll do that as well. One thing you'll notice is it added this internal access modifier. Because classes are open by public by default in Kotlin. When it converts something from Java, it'll use the internal modifier because in Java they're package private by default. So we'll just get rid of that. We need to make because that internal modifier is not there. This type recipe type is, since it's package private, we need to make it public. This medium here, not too crazy. All right, so one thing you'll notice is we have all these question marks on these strings. This is just to indicate that this is a nullable type. I'll talk about that a little bit later, but essentially what this is saying is Kotlin adds a distinction to type signatures to say if they can be null or not, which is really cool. Also, you'll notice that it got rid of all the getters and setters. One of the things about Kotlin that it strives to do is remove boilerplate when possible, and to do that intelligently, allowing you to kind of flex up to have more complicated things if necessary, but in general, it tries to keep them pretty simple if possible. And so the way this works is that in Java, we have access modifier, or we have getters and setters because we want to hide the internal implementation of how these things are stored. And if it changes later, we don't want that to affect our calling clients. The way we can do that in Kotlin is we can add these getters here, and we can say, maybe for the get here, we want to make name always uppercase, so we just return. And now when the getter is called, it will be uppercase. And that allows us to have a very simple class declaration from the outset, but if we want to change something about the way it's accessed later, we can do that without it breaking our callers. The nice thing is when someone accesses this property directly from within recipe, for example, here where we have this test function, and I have a recipe, if I do recipe.name, when I call .name, it will call into this getter to get that value, which is really nice. You'll also notice that there's no new in Kotlin as well. Cool. Yeah, so this is nice. This is pretty concise, but we have these toString equals hashcode things down here as well. Those are fine, but the thing that's a pain in the ass about these is if you add a new parameter up here, it won't get added to the toString unless you do it manually. You'll notice that I added this calories value earlier, but I forgot to add it to the toString. That kind of sucks. That's a problem. In Java, you have things like Lombok that'll do that for you, but Kotlin provides a nice feature out of the box called data classes. And so one thing that you can do with Kotlin is basically there's this idea of a primary constructor. So the way you can declare a primary constructor is you just use parentheses here. And what this does is it is essentially equivalent to declaring private instance variables and then setting those as part of the constructor. This syntax here, this equal null, this is actually giving a default value for all of these different things here. So what this essentially is equivalent to is, your typical Java thing where you have, you have this value here, and then you might in the constructor set it later or something like that. Yeah. So, but what we can do is we can change this to be a data class. And data classes in Kotlin are supposed to be just like containers for data, very simple. Think about like a POJO in the truest sense, where literally just it's like a value type. Stuff goes here, and it's just a container. Now, if you have your test function here, you have your hash code, toString, all those are implemented for you as part of the data class, and it makes stuff a lot easier there. Cool. All right, so going through this pretty quick, a couple other things I want to talk about are extension functions in Kotlin. So Kotlin has extension functions similar to something like C# if you've been exposed to that. So I have this utility class here, which I have this method that allows me to do a toString call, but not care if it's a null or not. So I don't have to worry about getting a null pointer exception. So I'm going to convert this file to Kotlin. And you'll notice this object keyword. An object in Kotlin is essentially, the object keyword is used to signify an object which has a single implementation. Think about like a singleton in Java is the same kind of idea. It's also used as kind of like it's similar to how like static methods are defined in Java. All right, so what we can do here is actually, we don't even really need it to be in an object because we have package level functions, so we can just move that out. And now this is fine, but now we have to, know to pull in that method and all that kind of fun stuff. But what you can actually do is you can declare it as an extension on this type T. And now what you get is the ability to call this null safe toString directly on a value. So for example, if I have our function here, and let's say I have a recipe, but it's null. I'm going to give the question mark here to signify that. Now I can just do recipe.nullSafe this string, and it's there right on the. Oops, so get rid of this, because then it is just going to be this in the function. And yeah, there we go. So this is cool because it allows you to extend pieces of functionality that may not be there. This is basically saying on literally any type T, I now have this function null safe toString. So whether that's an integer, whether that's a string, whatever, which is kind of cool. All right. Kind of going at a high level here. Yeah, so this is a controller in Spring. We're going to convert it to Kotlin here. Nothing too crazy. You'll notice that this auto-wired annotation is going to go above the constructor here, and that guy goes there. Fun, fun, fun. It's also using that custom getter to get that, and it's using what we call single expression functions. So in Kotlin, if you have a function that just takes a single line, you can use an expression as opposed to a full function body. Yeah, so I'm just going to dive into the recipe service here. This is kind of the meat of our application. It has a bunch of complex logic. It has all kinds of fun stuff going on here. So I'm going to convert that to Kotlin, and then we'll talk about a few things. All right. So one thing to notice here is this best recipe call is an optional. It's optionals in Java are kind of a way to handle nullability as well. And so this is sort of the solution to nullable types in Java APIs. And basically this is saying, hey, this thing could be null, so you should always be forced to handle it. So in this case, we're saying, okay, well, if it's not, we'll just do a null, not a big deal. But what if at some point later in the future, we realize that best recipe is capable of, we're sure that it's not going to be null. How do we handle that? Well, we go to our API over here, and we're in this best recipe. And so what would happen? Well, just going to fix a few things that the conversion didn't like. The type inference is pretty smart, so I can just get rid of all these. Since we changed this to a data class as well, this is going to be just the rating. Cool. So this function here returns two things. First off, you'll see here that we have these two functions that are one has 0 parameters, one has 1 parameter. This is kind of the way that you would have to handle default parameters in Java. In Kotlin, you can just get rid of this guy and make this default to false, which is nice. We'll make this no longer private. Cool. So let's say that I know now that this is never going to return null, and I want to tell my callers that, hey, I'm sure that this is not going to be null. I'm going to get rid of this optional, and life's going to go on. It's going to be great. I'm just going to get this directly, and yeah. But the problem is there, once I change that, if I go back to the controller, it breaks the caller because I've changed the interface, which really sucks. The nice thing about nullable types is that if this was originally a nullable type, say it could be any recipe or the value null, and we go here into the controller, we would have to handle that in a different way. Kotlin allows this thing called an Elvis operator, which basically says, if this thing over here evaluates to null, then do this over here. And I'm going to just call the name is not found or something like that. One of the cool things about Kotlin as well is you get name parameters by default, which is sweet. So this kind of solves one of the problems that you can get in Java where you have 20 arguments in a method. It's really hard to know what, maybe there's like 9 numbers, what number is what. You'll use a builder to solve that sometimes, but this is a nice way to solve that as well. So now I have this nullable type, but let's say I do the same thing. I realize later, hey, I can be more strict about what I'm saying. I can offer a better guarantee to my caller. So I'll remove that null, and I go back to my controller, and it doesn't break, which is really cool because then I can strengthen the contract without it affecting my callers. But the compiler will inform my callers in the future, hey, you don't need this null checking anymore. I'll just remove it, right? So that's cool. Yeah, going back to the recipe service, a lot of fun stuff in here. One of my favorite things about Kotlin is this idea of string templates. If you've ever had to deal with generating long strings in Java, it can be a pain in the butt. So let's go over here. Here's this null save toString method that I defined earlier. So we'll just do this on best. So best null save toString. What we can do instead is actually this thing called a string template. And so if we move this into the string and enclose it in this little $ open brace notation, it'll just automatically do that for us. You can also do, if you're, let's say you just want to do whatever toString implementation it has by default, you can just do a $ and it's there, which is really nice. Saves a little bit of time there. Cool. One of the other fun things about Kotlin is this idea of scope functions. So let's say you're using an API written by somebody who's not very nice, and they didn't supply a constructor with any arguments, and there's no builder. So you literally have to new up the thing, and then you have to manually set each individual value in that thing to what you're going to do. That's kind of a pain, and Kotlin offers this thing called a scope function to solve that problem. So instead of, basically you can do this thing called .apply, and then in that .apply block, there is the value. This is just a block, a function essentially, and in that function, the value of this is set to be whatever you do .apply on. So in this case, it's the recipe. So we can just replace all these instances of sample with this, and then it's also this is returned implicitly at the end. So we can just return this guy here. And yeah, so that's nice. But even better in Kotlin, this is always optional. So you can get rid of this. And you have this nice little block, which looks a lot better than it did earlier. And it, all this stuff about removing lines of code, removing boilerplate, it sounds like it's just like, oh, whatever. If you've worked with Java for a very long time, you're used to boilerplate. But boilerplate is noise, and noise is a really easy place for bugs to lie without you realizing it. And so one of the nice things about removing boilerplate is you are much more concise and intentional about what you're trying to convey with your code. And that way, if there's an issue, it's easier to see where the issue is, which is cool. All right. So a couple other things I want to talk about. Kotlin has this concept of val versus var. If you're used to JavaScript, think const versus let, very similar. Not going to go too much into detail there. One of the things to think about as well is you'll notice that I didn't change any of the APIs I'm interacting with at all at this point. One of the things that's kind of daunting about going into a new language, think about going into like Node, for example, if you're a Java Spring developer. You know how to write server-side applications, but the way a Node application is structured and the APIs and the conventions are very different than you might be used to in Spring. Switching to Kotlin, you don't have to pay any of that cost at all. You're using the same APIs, the same frameworks, everything you would have done before. It's just nicer. So it's a really, really simple place to drop in. You'll also notice that I changed one single file to Kotlin and still a primarily Java application. So you can whittle away at this piecemeal. You don't have to do go on a 4-year process to convert your entire app to Kotlin. You can do it a little bit at a time, making small improvements. New files can be in Kotlin while still maintaining the legacy Java stuff and improving the app without having a real large cost to developers. One of the nice things about Kotlin too is that we have they have really good collection APIs. So this is a function which basically says, given a list of all recipes, recipes have a list of ingredients, right? And so I want to find what ingredient in those recipes is the most common across all recipes. So what that essentially does is I'm converting it to a stream. I'm doing this flat map here. This does what I want it to, but it doesn't really communicate well what's going on. Like, it's really complicated. I'm sure if you've been unfortunate enough to work on a project with me, you've seen this kind of crap in Java where it's like kind of shoehorning a functional style where it maybe doesn't belong. So I'm going to try and write this in a little bit better way using some of the native collection APIs. You'll notice I'm just using normal Java 8 streams here. So I'll write a new function here. All right, so we're going to do the same thing. We're going to do recipe repository.allRecipes. We're going to flat map that, and flat map just takes maps to a list and it flattens that list. In Kotlin, declaring lambdas is really easy. Flat map is a function that takes a lambda. You start a lambda like this, then you can have your recipe, and then you can do recipe.ingredients, right? And I'm going to remove this return so it doesn't yell at me for the time being. Cool. So this one is a little bit yelling at me because I need to do the null coalescing operator here. And yeah, so this is fine. But Colin's saying, hey, you should move this lambda out of parentheses. And that's because if a lambda is the last argument in a function in Kotlin, you don't need the parentheses, which is nice. So that makes it a little bit more concise. Also, what you can do here is you don't actually have to specify the parameter here. In Kotlin, that's just assumed to be it by default. And let's see, what is it telling me? String. Cool. Oh, so in this case, it's just wanting me to say, hey, that could be null. So we're just going to do an empty list otherwise. All right. So now at this point, we want to group by, and here what we're going to do is we're going to group by it dot. We're going to group by it, and so what this is going to do is it's going to yep, and then here we can do all the entries, and finally we can max by it dot value dot length size, I should say, and then cool. And so here, what this is doing, I think, kind of probably not super clearly shown, but I think that this is a much more clear way to communicate the intention than this code up here, even if I kind of explained it a little bit poorly. This is having these collection functions as a sort of, A, there's just more of them and that are better in Kotlin, but B, they're also, I think, able to communicate the intention a little bit better than having to do the stream and flat mapping and going back to a stream. And it's kind of, there's a lot of noise here that you don't have in this solution that will kind of save you the problem of, oh, I have all this code that does what I need it to, but it doesn't actually tell me what it needs to. But yeah, so I'm getting low on time here, so I'm going to kind of go back out into the keynote function for just a bit. But yeah, so Kotlin is awesome. It has a lot more functionalities than I talked about today. I didn't really even touch on some of the cool stuff. Really what I'm trying to do is get the idea of, hey, if you're a Java developer and you think Kotlin's interesting, it takes very little effort to go and play with it. And I think that everybody who does will be like, oh man, I wish I only wrote Kotlin from here on. So yeah.